All right, today we're putting on our detective hats. We are opening up the case files on some of the universe's most fascinating mysteries, from a strange visitor from another star system all the way to a puzzle that stumped one of the greatest minds in history. So let's get started.
Our first case file opens with this object. It's a comet, and its name is 3I/Atlas. But listen, this is not just any comet. Its unbelievable speed and its totally weird trajectory tell us one thing for sure. This thing is an interstellar visitor. It's a traveler from a solar system far, far away from our own.
So who exactly is this mysterious guest? You can almost think of it like a cosmic message in a bottle. As soon as astronomers spotted it hurtling towards us, the hunt was on to figure out where in the universe it came from.
Okay, clue number one. Its speed. It's absolutely tearing through our solar system at a mind-boggling 130,000 miles per hour. I mean, to put that in perspective, that's fast enough to circle the entire Earth 5 times in just 1 hour. That is not the speed of something that just wanders around our neighborhood. That's the kind of velocity you get from being flung across the galaxy for millions, maybe even billions of years.
And then there's clue number 2, its size. This thing is a monster. Recent estimates suggest this icy wanderer could be up to 7 miles wide. That makes it way bigger than a mountain, and by far the largest interstellar object we have ever seen. A true cosmic giant.
And here's what makes this case so incredibly important. This is only the 3rd time ever that we've been able to confirm an object from another star system has paid us a visit. After Oumuamua and Borisov, 3I/Atlas is this incredibly rare chance to get a look at a piece of a totally different part of our galaxy.
So with the evidence piling up, astronomers did what any good detective would do. They started to trace this suspect's path backwards. They were trying to figure out exactly where this cosmic ghost came from in the first place.
You know, figuring out where it's going is the relatively easy part. We can see its little tour of our solar system laid out right here. After it was confirmed, it's going to zip past Mars and the Sun in late 2025, and then swing by Jupiter on its way back out into deep space in 2026. But knowing its future just makes one question way more urgent. Where was it before it got here? And this is where the real detective work kicks in. Using a ton of data from the Gaia Space Telescope, researchers basically hit rewind on the comet's journey. They traced its path back 4.27 million years, and they identified every single star it probably passed along the way.
And here is the bombshell. After checking all 62 of those potential star systems, the lead author of the study, Xavier Perez Cuato, basically said that none of them could be the comet's home. Not a single one could have given it the gravitational kick it needed to reach that insane speed. So the mystery just got a whole lot deeper.
So if it's not from our neighborhood, then where is it from? Well, this led researchers to a really cool new theory. See, our Milky Way galaxy has 2 main parts. There's a thin disk, which is where younger stars like our Sun live, and then there's a much older, thick disk, which is kind of like this galactic frontier, filled with ancient stars made of the really early primordial stuff of the universe. And that points the finger at the prime suspect, the ancient thick disk. And if that's true, it implies something absolutely stunning about its age. This comet isn't just a visitor from another star, it's a visitor from another time. It could be a 10-billion-year-old relic that's more than twice as old as our own sun. It's a genuine time capsule, a perfectly preserved piece of the stuff our galaxy was made of right after it was born.
You know, this whole process of using data to solve a massive puzzle, well, it has a long and very rich history. So for our next case, we're going to jump in our time machine and go back a few centuries to meet one of the original cosmic detectives, a man named Johannes Kepler.
Kepler was staring down a mystery that had baffled people for thousands of years. Why do the planets move the way they do? He was totally obsessed with the weird case of Mars, which, from our point of view, would sometimes just seem to stop in the sky and move backwards. The models that everyone used back then were getting ridiculously complicated trying to explain it.
For centuries, the best answer anyone had was this. Well, this complete mess of circles within circles called epicycles, which you can see on the left. It was a crazy system designed to do one thing: keep Earth at the center of the universe, no matter what. But Kepler, he had the best data of his time, and he just had a gut feeling that the truth was way simpler, something more like that elegant ellipse on the right. This was a revolutionary idea, shifting from just trusting old philosophy to actually trusting the hard data.
Now, what I love about this is that it shows even the most brilliant minds can start with the wrong idea. This was Kepler's first shot at it, this beautiful geometric model. He thought the orbits of the planets were perfectly nested inside these 5 perfect geometric shapes. I mean, it was elegant, it was profound, and it was completely, totally wrong when he actually checked it against the data. But you know what? That failure is what pushed him onto the path to find the real answer.
After years of just grinding through calculations, he finally cracked the case. He completely threw out that ancient obsession with perfect circles and discovered his 3 laws of planetary motion. First, planets move in ellipses, not circles. Second, they speed up when they get closer to the sun and they slow down when they're farther away. And third, there's this beautiful hidden math that connects how big a planet's orbit is to how long it takes to go around the sun. He'd done it. He'd solved the mystery.
So Kepler solved one of the biggest mysteries of his day, but in doing so, he opened the door to countless new ones. It turns out the universe is just a giant book of riddles, and for every single page we manage to turn, we just find more and more questions.
I mean, take the cold case of Mercury. For a planet that's so small, it has this impossibly huge metal heart. Its iron core makes up over 70% of its entire mass, which it doesn't fit with our models of how planets are supposed to form. So why? Well, the leading theory is a pretty violent one. A massive ancient collision might have literally blown away most of its rocky exterior, leaving behind this super dense heavy metal world. But right now, the case is still open.
Or what about the totally bizarre case of white dwarfs? These are the dead bodies of stars like our sun. I want you to imagine taking the entire mass of our sun and crushing it down into a ball the size of planet Earth. Gravity should just completely smash it, so what's stopping it? The answer is this weird quantum force where electrons just refuse to be squeezed any closer together, creating this incredible outward pressure that can actually hold up a dead star.
And the mysteries just keep getting bigger. We go from single objects to entire cities of galaxies, like the Fornax cluster you see here, all held together by gravity across millions of light years. These are the largest structures in the entire universe. How do they even form? How do they change over time? It's like this cosmic dance of gravity playing out over billions of years, and we are just starting to figure out the steps.
So from a mysterious comet to the motion of the planets, all the way up to the structure of the cosmos itself, this is our unending quest. And every single mystery we investigate teaches us a little bit more about our own place in this universe.
And a huge clue to how we solve these mysteries is right here in this quote. It's a great reminder that no detective really works alone. Kepler needed the data from another astronomer, Tycho Brahe. Today's astronomers need data from amazing telescopes like Gaia, which are built and run by teams from all over the world. See, science isn't just the work of some lone genius. It's this huge global team effort built across generations.
So when we look out at the cosmos, at a galaxy like this, we're seeing a vast landscape of unsolved cases. Each one is a clue to the fundamental laws that make reality work, and the investigation is far, far from over.
The work of the cosmic detective, it seems, never truly ends. Because for every single mystery we solve, we just end up uncovering a dozen more. And each one seems deeper and more fascinating than the last. The only real question is, what are we going to ask next?